Don't be scared. Don't let this scare you. Look at this. We're going to start with some horrible expression up there, and we're going to make a differential equation. We're going to show that this satisfies this differential equation. I'm Nick here at Nick Does Maths. Buckle up, buckaroos. Let's do some fun stuff. Now, this does not look pleasant, and then it looks like we're going to want to differentiate it not once, not twice, but 3 times. But let's not panic. Let's see what happens. We don't have a choice. We're going to have to differentiate it once, so let's do that. Differentiate the 2x, keep the arc sine 2x. All right, then keep the 2x and differentiate arc sine 2x. Now arc sine 2x, we're going to get a 2 from that over square root 1 minus 4x squared. And now we need to differentiate this. So chain rule, we're going to differentiate the 1 minus 4x squared, which will give me minus 8x. And then differentiate that square root, times a half. There we go, because it's a square root. All right, now 2x times 2 is 4x. 8x times a half is 4x. So what's happening, that's going to, didn't want the red anyway. What's happening that will make me very, very happy is I get some nice cancellations. So that's already very, very nice. So we're going to come back to that in a second. Now, all of a sudden, I'm a lot less scared about differentiating again. So let's differentiate that again. Differentiate 2 arc sine 2x. I'll pick up that 2. I'll pick up another 2 there. That is 4 over square root 1 minus 4x squared. Okay. All right. Now then, where are we going to go from here? Where are we going to go from here? So these are my 2 main solutions, and just to clear up a bit of space, all of that's cancelled out. It doesn't need to be on the board anymore. First thing we're going to do is we're going to plug that into there. So we get y. I want that 2 to go with the arc sine. Right, 2 arc sine x, 2 arc sine x. So that becomes x dy by dx plus square root of 1 minus 4x squared. Now then, if I'm going to multiply, what I'm going to do now is I'm going to multiply this entire thing through by d2y dx squared. Why would you do that, Nick? What is wrong? Have you finally lost all leave of your senses? Well, I have and I haven't. And why is that? Because if I multiply this up, I get the fact that square root of 1 minus 4x squared times d2y dx squared is actually 4. So what I can actually say now is that y d2y dx squared is equal to x dy dx d2y dx squared plus 4. Now what are we going to do? Now what are we going to do? Well, I don't really like that. But what we can do actually is we can start, so looking at what we get here, I will get, if I move that over and factorize, I will get d2y dx squared times y minus x dy dx is equal to 4. And now all we need to do is we need to differentiate. So differentiate the d2y dx squared, that's d3y dx cubed, keep that bracket, plus keep the d2y dx squared and differentiate the bracket. So y becomes dy dx minus, differentiate the x, keep the dy dx. Well, that is handy. Keep the x, differentiate that. And that is quite handiferous. And all of that is equal to 0. Right, so let's finish this off. We are pretty much there. Because what can I do? Well, I've pretty much got it. All I need to do is move that term over to the right-hand side, and I get my result of d3y dx cubed of y minus x dy dx is equal to x times d2y dx squared. So there's no issue with rearranging these things and plugging them back into expressions, right? As we do more and more maths, we get more and more comfortable playing around with entire expressions and subbing them into equations. We don't always need to solve for x and sub it in. We can just get evaluations, we can get values for entire sub-expressions and plug them back in, right? Oh, look, what's all of this? Plug that back in. Oh, look, 2 arc sine 2x, that's horrible, but if I call it dy dx, that's much easier to differentiate, and we are up and running. So, nice little bit of trickery there for us. If you enjoyed this, please don't forget to like, subscribe, drop a comment, and hit the notification bell button. That's down here, down there, down there, down there, down there. I am Nick. I will be back soon with more of this. Keep doing maths, keep being awesome, keep being cool, and I will, ooh, I said that. And I will see you next time here at Nick Does Maths. Bye-bye.